Do you know how many kinds of functions are there?
No, sir.
Do you know how many kinds of functions are there?
No, sir.
See, basic definition of a function is
Yes.
A is a set and non-empty set.
Yes.
Elements of A are 1, 2, 3.
Yes. So your screen is not shared.
Oh, not shared. Okay, okay. Yeah. A is a set. Elements of set A are 1, 2, 3. Set of elements 1, 2, 3. B is another set. Elements of B are 4 and 5. Now, it's a new operator. This operator is in sets only. This is called Cartesian product. Cartesian product.
Yes.
You know, Cartesian product of two sets. Cartesian product of two sets. Its symbol is cross. Its symbol is cross. For example, if we want the Cartesian product of A and B, that is A cross B. This is Cartesian product of two sets A and B. A and B, sorry, A cross B is nothing but the set of some order pairs. Set of some order pairs. That means Cartesian product contains the elements like this. Elements in Cartesian product are like this. If you take the first pair is 1, 4. The second pair is 1, 5.
1, 3,
Next pair is
2,
4,
4,
2,
2,
5, 3, 4,
3, 3, 5.
3, 5. The same Cartesian product can be expressed through a diagram. The diagram is one, 2, 3, 4, 5. 1, 4, 1, 5. 2, 4, 2, 5.
3, 4, 3, 5.
3, 5. Same can be expressed on graph also. One, 2, 3. 1, 2, 3, 4, 5. Now, first 1, 4. 1, 4. It is 1 point. 1, 5. 2, 4. 2, 5. 3, 4. 3, 5. Right? Now,
Yes.
let's think about the subsets of. Let's think about this subsets of A cross B. This set A cross B has some subsets. This set A cross B has some subsets. See, what are these subsets of A cross B? Let R1 be the one of the subset of A cross B. R1 be the one of the subsets of A cross B. Pick some elements in A cross B. Any of your choice?
2 and 4. 2, 4.
Yeah, 2, 4 is one of its elements. Okay.
And 1, 4.
1, 4, right?
2, 5.
2, 5.
That's it, sir.
Yes. This is one of the subset. Okay. How many elements are there in A cross B? 3 and 3 2s are 6.
Yes.
1, 2, 3, 4, 5, 6. 6 elements are there in total A cross B. Number
Yes.
of elements in A cross B are 6 because A has 3 elements, B has 2 elements. 3 times
Yes.
2 is 6. That's why total number of elements are 6.
6.
And there is a formula also. That formula is N. You know the symbol N of. N of means
Number of
A. Number of elements in A is denoted by this symbol N of A is equal to 3. That means the set A contains 3 elements. N of B.
yes.
Number of elements in B. That set contains 2 elements. That's why N of A cross B has 3 times 2. 6 elements. Right?
Yes, sir.
It is one of its subsets. So here, number of subsets in A cross B, that is called N of P of A cross B. There is one concept. See, if you take A, A has how many elements?
3.
What are the subsets of A? 5. Empty set is also subset of A. That means 5 contains all the elements in 5 are from A only. Next, R1, singleton 1,
Yes.
right?
Yes.
R2, singleton 2 is subset of A. Agree?
Yes.
R3, singleton 3.
Guilty.
R4, 1 comma 2, it is a subset. R5,
1,3.
very good. R6,
2,3.
very good. R7,
2,1.
1 comma 2 comma 3.
2.
Every set is a subset of itself. That means the number of all the elements in R7, all the elements in R7 are that are from A only. No
Yes.
other element in R7, no element in R7 is not out of A.
Yes.
All the elements in R7 are from A only.
Yes.
R7 contains the elements from A only. There is no element out of A. Okay.
Yes.
Tell how many subsets are there?
6.
No. Count them.
7.
No.
7. Oh, over here. 1, 2, 3, 4, 5, 6, 7, 8.
8 subsets are there, right? So, number of elements in A, number of elements in A power. It is called P of A, P power A. Number of elements in it are 8. It has 8 elements. You know why? Number of elements in it can be obtained by the formula 2 cube. 2 cube is equal to 8.
Yes.
Since it has 3 elements, since A has 3 elements, number of elements in it are 2 cube, 8 elements.
Yes.
Among them, 5 and itself is called improper subsets. That means the subset 5 is subset for any set. Not only for A, it also for B also. And itself is a subset. It is there for any set also. For every set, we can write a subset of it, that is itself. That means taking all the elements in it.
Yes.
So, these two sets are called improper subsets. These two are improper subsets. Rest of the subsets are called proper subsets. Number of subsets of a set. Number of subsets of a set are 2 power n. Number of subsets of a set are 2 power n. Number of proper subsets of that set are 2 power n minus 2. Number of subsets is 2 power n. Number of proper subsets is 2 power n minus 2. Okay. Sometimes this may be asked like this. Number of subsets other than itself. That is 2 power n minus 1.
Yes.
Number of subsets other than number of non-empty subsets. That also 2 power 1. 2 power n minus 1. Other than non-empty subsets means we exclude only 5 only. Right. It has another name. That name is called null set. Null set and empty set both are same.
Yes.
Null is a German word. It means 0. That's why this word is entered. Null set, null matrix, where null means 0. Okay.
Yes.
Now, please tell how many elements that A cross B contains. So sorry, number of subsets that A cross B has.
6.
A cross B, 6 elements are there.
6.
How many total subsets are there for A cross B?
6, sir.
No.
Oh, total subsets.
Total number of subsets.
2 to the power 6.
Very good. If we want only proper subsets, it is 2 power 6 minus 1. What's the value of 2 power 6?
Let's say
2 power 6.
4, 8, 64.
Very good. So we can write 64 subsets of this kind. We wrote R1. Like this, we can, if we want to write all the subsets, we need to write how many subsets?
64.
64 subsets. Among those 64 subsets, some subsets have a special property. That property is, observe the subset I am writing. R2 is equal 1, 4, 2, 5, 3, 5. This type of subsets are 8. 8 subsets are of this kind. What is the specialty of this subset? For example, if we take R1, in R1, we take the first elements that are 2, 1, 2. But these elements are taken from A only. If we take the first elements that are 2, 1, that's it only. We need not write 2 again. Of course, we can write. If we take the first elements in every order pair that are 2, 1, 2. Of course, these elements are taken from the first set. The first set has 1, 2, 3. But in R1, we use only 2, 1, 2. 2 is used 2 times and 3 is not used. If you take the set, the first elements are 1, 2, 3. All these elements are from A only, right?
Yes.
And one more thing, all the elements in A are used. Unlike R1, here 3 is also used. That means all the elements in A are used. And one more thing, here 2 is repeated. But here no element is repeated. This subset has 2 properties. The first property is use all elements. Second property is no repetition. It's all about the first set only. We are not talking about second set.
Yes, sir.
Right? Can you create another subset of A cross B? Obeying the conditions, all elements in A should be used and no repetition is allowed. Without repetition, all the elements in A are used. Those elements to be picked up from A cross B. Try
1 and 4.
Tell again.
1, 4.
Very good.
2, 5.
Right.
That's it, sir.
Yes, of course. Of course, you may write 3, 4 also. But if you stop there, you missed the element 3. Okay.
Yes, sir.
All the elements in A are used. And no repetition is there. No repetition of elements in A are there.
Yes, sir.
Next, tell another subset.
R4 equals.
Of course, we may write 1, 4, 2, 4, 3, 4. Don't bother about the elements in B. About the elements in B, whether they are all used or not, or is there any repetition for the elements in B? It's not matter. Of course,
Yes,
here
sir.
4 is repeated, no problem. But the two conditions are all the elements in A should be used and repetitions should not be there.
Yes, sir.
Can you tell another set, another subset?
1,5, 2,5, and
1,
3,5.
5, 2, 5, 3, 5. See, the difference between these subsets are R1 is a subset, R3, R4, R5 are subsets. The difference between among these subsets is this subset doesn't follow these two rules. These four subsets R2, R3, R4, R5 follow these two conditions. The subsets of A cross B, the subsets of A cross B, which follows these two conditions are called functions. It is the flashback of functions. That only called functions. Please tell, do you think that R1 is a function? R1 is a function? No. R2?
R1, sir? No, sir.
R2
R2.
is a function.
No.
R2, R2.
So here 1, 4, 2, 5. Oh, yes, it is.
R3?
Yes, sir.
R4?
Yes, sir.
R5?
Yes, sir.
But R1 is not a function.
Yes, sir. Because the X values are repeating.
Yes, yes, X values are repeated. We don't bother about the Y values, right? And now tell, what's the name of R1? R1 is not a function. Then what's the name of R1? Name of R1 is a relation. R1 is called a relation. R1 is a relation. R3, R4, R5 are also relations. R3 is a relation, R4 is a relation, R5 is a relation. R3, R4, R5 are also called relations. Apart from being relations, R3, R4, R5 are called functions, right? Now, is there any option to erase bulk spaces? I think no.
No.
We may clear all the writings in page at once.
Yes.
Can you imagine how many functions can be created from this A cross B? We have already created 4 functions.
Yes, sir.
4 functions are created, right? How many functions can be created?
Infinite. I don't know.
No, not in total number of subsets are 64 only. So number of functions is less than 64.
Yes, sir. Got it.
Less than 64. R6 is a function, right?
Yes.
Try to create as many functions as possible. R6.
3, 4, 3.
Yeah, right from 1.
Oh, so 1, 5.
Very good.
2, 5.
Very good.
And 3, 4.
Very good. Next.
1, 4, 2, 4, and 3, 5.
1, 4, right? 2,
2, 4,
yeah,
and 3, 5.
very good. Next, R8. One comma 4, 2, 4, 3, 4 is over. 1, 5, 2, 5, 3, 5 is over. 1, 4, 2, 4, 3, 5. Next, 1,
5,
yeah,
2, 4, and 3, 5.
2, 4, 3, 5. Very good. Next, R9.
1, 4,
1, 4.
2, 4. Oh, no. 2, 2, 5 and 3, 5.
2, 5 and 3, 5. Not there? Yes. Count total number of functions are?
9, sir.
No. R1. We started from R1, but R1 is not a function.
Oh, 8, sir.
8. So see, the number of functions has a formula.
Yes.
The number of functions is exactly 8 only. We cannot create another function.
Yes.
Number of functions. Two cube. How to get the value of number of functions? Number of elements in B to the power of number of elements in A.
Yes, sir.
Formula to find number of functions is, tomorrow you will have
Power.
a lot of questions from this theory.
Yes, sir.
So what is formula to find the number of functions from B, A to B? N
2
of
to
B,
the power.
N of
2
B
to the
whole power N of A.
Okay.
Number of subsets, sorry, number of relations, 2 to the power of N of A into N of B.
First one's
A has 3
functions.
elements, B has 2 elements. 3 times 2 is 6. 2 power 6 is equal to 64.
Yes.
So out of these 64 relations, number of relations are 64. Here the sets A and B has, the sets A and B has 64 relations.
Yes.
Among those 64 relations, 8 are functions also. Among those 64 relations, 8 are functions also. Got
Yes.
it?
Yes.
See, for example, out of those 64 relations, tell one relation. Do you remember R2?
No.
1, 4, 2, 5, 3, 5.
1, 4, 2, 5, 3, 5.
1, 4,
2, 4, 2, 5, 3, 5.
1, 4,
2, 5, 3, 5.
1, 4, 2, 5, 3, 4, right?
Yes.
Yeah. See, the same function can be expressed like this. This is set A. This is set B. Elements in A are 1, 2, 3. Elements in B are 4, 5.
Yes.
The relation is called R2. R2 is the, sorry, R2 is the function. Of course, it's base. First, it is a relation. Now it is a function also, right?
Yes, sir.
Now, 1, 4, 2, 5, 3, 4.
Yes.
Observe this. No repetition from A is there. That means 1, 2, 3. Association formed from A, from 1. There is no this type of association. From 1, only one association is there. From 2 also only one association is there. From 3 also only one association is there.
Yes.
If we take another, if we take R1 as we drew previously, R1 contains this type of associations. That means it is 1, 4, 1, 5. 1, 4, 1, 5. See, if we can see this type of association, it's very sure that it is not a function. And this also a relation, there is no doubt. Without this element, R1 is still a relation. If you draw this relation, 1, 4, 1, sorry, 1, 2, 3, 4, 5. If you draw this relation, that is 2, 4, 1, 4. 2, 4, 1, 4. But as 3 is not used. So if we see any element unused, and if we see any element repeatedly used, then it is not a function.
Yes.
To be called it a function, no unused element can be seen.
Yes.
No repetition should not be there. If any relation following that two conditions, that is called function. That means if you see associations like this or this, it's not a function. If we see any unused element, it is not, sorry, if we see any this kind of function, this kind of associations, it's not a function. If we see any unused element, it is not a function. Got it? See here, yeah, there is no this type of associations. There is no unused element. So clearly it is a function.
Yes.
The same function can be drawn on a graph also. First 1, 4. This is one part. Next 2, 5. Next 3, 5. So it is a function. This is R2. This is R2. This function, this line is R2. Of course, every time we cannot expect a line. We cannot expect a line, right? See, without those numbers, can you tell if this is a function or not? We are not using those 1, 2, 3, 4, 5. We are using ABC DE.
Yes, sir. I'm
Okay,
back.
okay.
Had a technical issue.
Is it the Wi-Fi?
I don't know what's wrong with the Wi-Fi. I had to connect with my mobile data.
Okay, okay, okay. I think among the world, India gives the cheapest mobile data.
Oh, is it? I think so, sir. I'm not sure.
See now, Geo is cheapest here, cheapest network.
Yes,
Geo,
yes,
Geo provides, even though it gains the highest profits among network providers.
providers.
See, uh, not considering, not considering the 1, 2, 3, 4, 5, we are taking another example. A comma E, B comma D, C comma E. Do you think that is it a function or not? Do you
It
think
is a
it is a function?
function.
Don't bother about A and C have same image.
Yes,
A and E have same image. Okay, it's not the matter. There is no problem for two different elements having same image, right?
yes,
And if we see, it's very important point. That point is, if we draw a function on graph, if we draw a function on graph, any function, any function cross y-axis twice.
yes,
This curve cross the y-axis twice. So
yes,
it's not a function.
Yes, sir.
It is just a relation.
Relation. Yes, sir.
If you crosses x-axis twice, no problem.
Yes, sir.
If a function crosses x-axis twice, it's not a problem. If a function crosses y-axis more than one, that means it is not a function.
Yes, sir.
Why it is not a function? That means element of, for example, if it is 1, if it is 5, okay, we can get the pairs like this: 0, 1 and 0, 5.
Yes.
0, 1 and 0, 5. That means 0 is repeated.
Yes, sir.
0 is repeated.
Repeat.
That's why if a function crosses y-axis more than once, it is not a function. Got it?
Yes, sir.
See, I'm drawing some special functions. See, it is x-axis, it is y-axis. See, it is a function. This type of functions are called linear functions.
Linear functions. Yes.
You know why it has this name?
So because it goes straight line.
A straight line. That's why it is a linear function. It is a linear function. And see, this is also a function. Okay, it is trigonometric function.
Yes.
If you draw sin x, on graph, the graph is like this. Because sin 0, 1. So one of the points is 0, 1. Sorry, sin 0, 0, 0, 0. It is the points here are 0, 0, right? Only. Next, pi by 2, 1. That means sin pi by 2, 1 only.
Yes.
Pi, 0. You know one thing, it is called function. There is no doubt in calling this as a function.
Yes.
You know, this function crosses x-axis more than once.
Yes.
Function crosses x-axis more than once. Even though it is called a function, there is no doubt in calling this a function, right?
Yes.
So this is linear function. These are a trigonometric function, right?
Yes.
You see, we discussed previously one special kind of functions, that is step function. Do you remember step function?
Yes, sir.
Step of 6.7.
6, sir.
Yeah, 6 only. This is a function. That function is called step function. You know the reason now why that function is called step function. The reason is here. If you draw the graph for that function, the function is graph is like this. This is the graph of step function. Got the reason?
Yes, sir.
What's the reason for that function is called a step function?
Because the graph is.
Yeah, the graph of it is, yes, steps.
Seems to be a step.
That's why the name of that function is step function. But its original name is greatest integer function. GIF, greatest integer function, right? See, one thing, it's very interesting. I strongly recommend you to get that book. What's that book? Play with Geometry.
Good job.
Yeah. This is function is y is equal to x. Linear function, of course, this function is y equal to x.
Yes.
This function is y equal to step x. Right? Surprisingly,
Yes.
we are drawing another function. These two functions are subtracted. This is step function. Y is equal to step x. This is y equal to x. Okay. Now, if it is 1. If you draw surprisingly x minus step x, take x is equal to 2.6. What is step x? X minus step x?
0.6.
2.6 minus step of 2.6. What is its value?
0.6.
0.6. What is 2.1? F of 2.1. That means 2.1 minus step of 2.1.
2.1.
0.1. So 2.1 comma 0.1. Next 2.2 comma 0.2. Got it?
Yes, sir.
What is f of 0.1? 0.1 only. That means 0.1 minus step of 0. That is 0.1 only.
Okay.
F of 2.1 is 0.1. F of 3.
Yes.
F of 3.1.
0.1.
Right. So if we draw graph for this, f of 0 is 0. Right. F of 0.1 is 0.1 only. F of 0.2, 0.2. F of 0.3, 0.3. Okay. Next, if this is like this, f of 2.1.
Oh, 0.1.
Very good. So this is f of 1.1.
0.1.
0.1, right? This is f of 1.1. 1.1 is 1.1. 1.2 is
0.1.
1 is 0.1. 1.3 is 0.1. So this is the graph. This is step x minus x graph. See
Yes.
how the graph changes. This is x. This is step x. X is step x. But the graph of x minus step x is like this. This is the graph of x minus step x.
Yes.
Just like this. And if we take, let's try to draw the graph of x square.
Oh, parabola, sir.
Yes, but it is not a graph. Sorry, it is not a function.
Oh, yes, sir.
F of x is equal to x square. F of -1 is equal to
1.
1. F of -2 is equal
Oh, 4.
to f of 0 is equal to
0.
f of +1 is equal to
1.
f of +2 is equal to,
4.
right? If you try to draw it on graph, we get a shape like this. See, image of -1 is
Once.
Image of -2 is?
4, sir.
Image of 0 is 0. Image of 1 is 1.
1.
Image of 2
2.
is 4. Previously, yeah. Yeah, no doubt. It is a graph. It is a function.
Sir, it's not a function of. Oh, wait. Oh, it is a function. Sir.
Yeah, because it is not crossing y-axis more than once. It crosses y-axis only once.
Yes.
See, it is a function. There is no doubt in saying it is a function. Yes, it is a function. There is another graph, that is x is equal to y square.
Yes, sir.
If you draw graph on this,
It will pass y.
please tell if x is equal to 1, yeah, if x is equal to -1, sorry, right. If y is equal to -1, if y is equal to -1, then x is equal, if y is equal to -2, then x is equal,
Y equals -2, sir.
yeah, -2. Then x is equal
4, sir.
+4.
Yes, sir.
Got it? So point here is 4, -2. X is 4, y is -2, right?
Yes.
If y is equal to -1,
1, sir.
x is equal to 1. If y is equal to -1, x is equal to 1. If y is equal to 0,
X equals 0, sir.
x is equal to 0. Right? If y is equal to 1,
1, sir.
1. If x is 1, right? If x is equal to 1, 2, sorry, if y is equal to
4, sir. Sorry. Yeah.
4. If x is equal to y is equal to 4.
4.
Sorry. If x is equal to 4, y is equal to 2. Got it?
Yes.
If you draw the graph like this, it is its graph. You may think that it is not crossing y-axis more than once. But I forgot to tell you one thing. If a function crosses more than once, it is not a function. If your function crosses y-axis more than once, it is not a function. And additionally, if any line drawn parallel to y-axis, which cuts that function more than once, even that case, that is not a function.
Vertical line test.
Any vertical line.
Yes.
No vertical line, okay, intersects that graph or that curve, whatever it may be, more than once, it is not a function. See, if you draw any vertical line for the first curve, it is a vertical line. So many vertical lines can be drawn. No vertical line crosses that function more than once. That's why it is a function. If you draw vertical line, only y-axis touches this function only once.
Yes.
Except y-axis, all the vertical lines on positive side of x-axis crosses that function more than once.
Yes.
That's why it is not a function. It is just a relation. It's not a function. It is just a relation. We will learn why it is not a function. Okay, why it is not a function in the next class. Of course, it's not a function. There is this valid reason. To say this is not a function without seeing the graph. Or if we avoid taking negative y values, that means if we don't take these values, then it is a function. If we are not using these values, that means That means this part of the graph is not there. Then it is a function.
Yes.
You know why?
Because the
It crosses right. And
line only.
see, y is equal to x square, you know?
Yes.
Y square is equal to x, okay? Then y is equal to root x.
Yes.
That means f of x equal to root x. Do you remember one thing? While finding its domain, we use any function, any square root function is defined only when x is positive.
Yes.
In the course of finding its domain, we use the concept x greater than 0. That means x is positive. Have you got the correct reason why this is why in finding the domain of this function we use this concept only?
Yes.
Remember it? In finding domain, we take x is positive one.
Yes.
Have you noticed the reason why? What happens if x is not greater than 0? That means if x is less than 0.
So root
If x is less,
negative something is not.
In theoretically we say that under square root no negative value should be there. If there is a negative value under square root, it can't be a real number. In theoretical explanation. But in graphical explanation, if there is a negative number under square root, the function graph like this, it can't be a function.
Yes.
In graphical explanation, it's not a function. In graphical explanation, it is not a function.
Yes.
When we take negative values under square root, we are taking these negative values. That means we are taking x value negative. So have you noticed the correct reason for?
Yes.
The square root of negative value is not a real.
Yes.
In theoretical, it is not a real number. In graphical, it can't be a function.
Yes.
Right? That's the reason. Okay. These are the very important basics of functions. We will learn step by step every point. Okay. I will provide you notes also. Okay. For a few days, and within 2 days, pre-final exams will be completed for these students, Josna's batch. After that, they will have class also. Then only we need to start at 4:30 or 4:15 to adjust the time. Till then, our class is 4:45 to 5:45. Okay, got it. And after this class, also I am teaching
trigonometry
basics. If you have time, you can also at the same time or later also.
Yes.
Okay, so join same time tomorrow.
Yes.
Just for a couple of days. After a couple of days, you will have your usual time. Okay.
Yes. Yes.